Principles of factorising quadratic expressions. Consider the product of the two binomials 2 times x add 3 and x add 4. Expanding this product gives 2 times the square of x add 8 times x add 3 times x add 12. This is a quadratic with 4 terms. If we collect like terms, we get 2 times the square of x, add 11 times x, add 12, which is a quadratic in 3 terms. In order to factorise this quadratic, we need to partition the term in x into the 2 terms. In this case, we know that the coefficients of the 2 terms are 8 and 3. But if we had to factorise this quadratic, we would not know the coefficients of the 2 terms to partition the original single term in x. To determine how the coefficients of the 2 terms are found, notice that in the expansion of our original binomial, the product of the coefficients of the 2 terms in x, 8 times 3, which equals 24, and the product of the coefficient of the square of x and the constant term, 2 times 12, also equal 24. The product of the required coefficients is equal to the product of the coefficient of the square of x and the constant term, and their sum is equal to the coefficient of the single term in x in the original expression. So, to find the required coefficients in our second example, we need to find the numbers whose product is the coefficient of the square of x, 3, and the constant term 8, that is 24, and whose sum is the coefficient of the original term in x, 14. To achieve this, we use the technique demonstrated in the previous video. 24 and 1 are factors of 24. These do not sum to 14. 2 is a factor of 24. 2 and 12 multiply to 24. These sum to 14. So we have found the required numbers 12 and 2. We partition 14 times x into 12 times x, add 2 times x. To get 3 times the square of x, add 12 times x, add 2 times x, add 8. The first 2 terms have the common factor of 3 times x, so it can be factorised to 3 times x times x add 4. The last 2 terms have the common factor of 2, so it can be factorised to 2 times x add 4, and these are to be added together. Both these 2 terms have the common factor x add 4, so the expression can be factorised to x add 4 times 3 times x add 2. And we have the complete factorisation of the original quadratic expression. If a quadratic to be factorised has a term which is subtracted, replace the subtraction with the addition of its negative, as in the following example. Here both the term in x and the constant term are subtracted. The term in x is replaced with the addition of -1 times x. and the subtraction of 6 is replaced with the addition of -6. We now find two numbers whose product is -12 and sum to -1. The systematic process of finding these numbers reveals them to be -4 and +3. The original term in x is partitioned into add -4 times x, add 3 times x. The first two terms have the common factor 2 times x and can be factorised to 2 times x times x add -2. The last two terms have the common factor 3 and can be factorised to 3 times x add -2. X add -2 is a common factor and can be factorised to x subtract 2 times 2 times x add 3. And we have the complete factorisation of the given quadratic. In summary then, to factorise a quadratic expression of the form a times the square of x add b times x add c, partition the term in x into two terms whose coefficients are such that their product is the product of a and c, and sum to b. When a term is subtracted, replace it with the addition of its negative.